This is the continuation of assembly language notation. In assembly language notation, we have already seen it is classified into three types: 3, 2, and 1. We have elaborately seen three address for the respective example of C is equal to A plus B, and two address is also seen. And the concept of one address instruction is explained. Now let us see what are the instructions to be carried out for performing the operation of C is equal to A plus B. That is the example which we have taken, right? So C is equal to A plus B is the operation which has to be performed using this single address. In this, the accumulator plays an most important value for performing the operation with the address mentioned in the instruction. Okay. um, Let us see. In register transfer notation, C is equal tends to A plus B is the operation to be executed. That is mentioned here. In this, the first step involves loading A, whereas the value of, let us see, let us take this is the accumulator, and this accumulator will be loaded with the value of A. Load A is nothing but we are fetching the data from the memory location of A and it is stored to the temporary register. That is the meaning, right? So here the value of A will be loaded into accumulator. Okay, then add B. Add B is nothing but, as I have said earlier, add B, the operation performed will be the data of the address location B will be added to the accumulator value, and the result will be overwritten back to the accumulator only. So in that step, the accumulator will be rewritten with A plus B, because accumulator already has the data of A. Now the value of B is added and it is stored on the accumulator itself. Okay. Then the third step involves store C, because the instruction is C is equal to A plus B. Now currently A plus B has been performed and it is stored on the accumulator. The accumulator value has to be copied to the address location of C. The instruction used is store C. In that time, the data from accumulator A plus B will be copied to the memory location of C. So these are the three steps involved to perform the operation of C is equal to A plus B, where load, add and store are the operations to be performed, and A, B and C are the memory addresses which plays the role of source and destination based on the instruction which we are giving on the operand. Okay. uh, the operand specified in the instruction may be source or destination depending on the instruction. In load instruction, the address A specifies the source operand. In first instruction, A acts as an source, and destination location is the accumulator. Okay, here the destination is accumulator. In other hand, C denotes the location in store instruction, whereas here C is the destination and source is the accumulator. Okay, whereas the source is the accumulator. This is mentioned in this below paragraph. So as we have said earlier, in first instruction the address A acts as an source. In third instruction the address C acts as an destination. So as I have said earlier, based on the operation which were mentioned in previously, load, store or add, the address location plays the role of both source and destination. Okay, so consecutively we have seen the same example of C is equal to A plus B, whereas in 3 address location it is of single instruction line, add A comma B comma C, whereas in 2 address the number of steps has increased into 2 instructions, move B comma C followed by add A comma C, and in 1 address it is further increased into 3 steps of instruction which involves load A, add B and store C. As I have said earlier, whenever we are reducing the address spaces which were used in the instruction, the number of steps involved in performing the instruction or operation will be increased. So in 3 address it is of one line address, and in 2 it is of 2, and in 3 in one address it is of 3 line instruction to perform the same operation. This is an another example to indicate the usage of 1, 2 and 3, whereas add ri, rj and rk, it represents rk is equal to ri plus rj. This is the operation to be performed. In that, for 3 address it is given as add ri comma rj comma rk. This is rk is the destination, r1 and rj are the source. It is of single line. For 2 address it is of 3 line. Move a comma ri, add b comma ri, move ri comma c. And in single address it is of 4 line instructions. Let us see about this example elaborately in the next session.